Okay, good morning or good afternoon. This video it's for my students to check the even exercises of page 18, which are obtaining derivatives or differentiating four functions by simple rules. So the general ideas that I'm going to solve them so you can check them if your homework is correct or not. So let's start with exercise number 2. Exercise number 2 is a function of three terms function, three terms function that is g of x equals to x to the 4 over 4 plus 3x squared plus 6. So first thing to do is dividing the derivative of g into the derivative of the three terms, x to the 4 over 4 plus the derivative with respect of x of 3x squared plus the derivative with respect of x of 6. And the rule we use is the sum rule, or the rule which is here in this side of the paper. Well, next thing to do is rewriting the constants out of the derivative. So it is going to this is going to be 1/4 of the derivative of x to the 4 plus 3 times the derivative of x squared plus the derivative with respect of x of 6. And this rule is the derivative of a constant times a function equals the constant times the derivative of the function. Then we just obtain the derivative of dx to the 4, which is 4x to the 3, plus the constant 3 times the derivative of x to the 2, which is 2x, plus 0. And what we use in this case were two rules. And finally, we simplify the coefficients. So this first term is x cubed plus 3 times 2x, which is 6x. And that is exactly the derivative or g prime of x. The second even exercise, it is a quotient. So you have two options over here. One of the options, the first logic option, is to use the quotient rule. But in this case, it's kind of different to the case we saw in class because the denominator is in only one term. So it is easier if you rewrite the function as the quotient of each of the terms, that is t to the 4 over the common denominator, that is t squared, plus 3t squared over t squared minus t over t squared. So by simplifying this function, you will be able to differentiate the function easy than if you apply the quotient rule. So the original function h of t, without doing anything related with calculus, is rewritten as t squared plus 3 minus 1 over t. So once you have the function over as it is, then you can obtain then the derivative with respect of t of h of t. That will be the derivative with respect of t squared plus the derivative with respect of t of 3 minus the derivative with respect of t of 1 over t that should be expressed as t to the negative 1. And this is the sum rule. The derivative of f plus g equals to the sum of the derivatives. And then we just continue by obtaining the derivative of t squared, which is 2t, plus the derivative of 3, which is 0 because it is a constant, and then the derivative of t to the negative 1, which is negative 1, t to the negative 2. And in those three derivatives, we use three rules. Actually, two rules. The power rule and the derivative of a constant rule. The power rule we use on the first and the third, and the second term was used the derivative of a constant. And finally, all we have to do is just simplify. So h prime of t will be actually 2t plus t to the negative 2 or 1 over t squared in order to rewrite the negative coefficient as positive. And in this case, the only rule that we use, it's not a derivative rule, but it's the rule that says x to the negative n, it is equals to 1 over x to the n. And that will be the result. Exercise number 6 is actually a quotient, and as the denominator in this case is a two-term denominator, we must apply the quotient rule. This is the quotient rule, so I'm going to apply the quotient rule, taking into account that f of x is the first function or the function on the numerator, so that will be f prime of s, or the derivative with respect of x, will be the derivative of 2s plus 5 times 3s minus 2 minus 2s plus 5 times the derivative with respect of s of 3s minus 2. And this is over 3s minus 2 squared. So the derivative of 2s plus 5, it will be the derivative with respect of 2s plus the derivative with respect of s of 5. And this time 3s minus 2 minus 2s plus 5 times the derivative of 3s minus the derivative with respect of s of 2 over 3s minus 2 squared. And what we used in this case was the sum rule. Okay, continuing doing this, the derivative of 2s, it is going to be 2, plus the derivative of 5, it is going to be 0, times 3s minus 2. I'm sorry about my handwriting, but this is not too easy to handle with this application. Plus, well, minus 2s plus 5 times the derivative of 3s, which is 3, minus the derivative of 2, which is 0, over 3s minus 2 squared. On this step, I use two rules, the derivative of a constant and the derivative, or the power rule, the derivative of a power. So this will be then equals to 2 times 3s minus 2 minus 2s plus 5 times 3 over 3s minus 2 squared. By doing the product, I get 2 times 3s, 6s minus 4 minus 6s plus 15 over 3s minus 2 squared. And by simplifying the terms, 6x minus 6x, it is negative 4 minus 15, which is negative 19 over 3s minus 2 squared. And this is just a simplification because we have already done all the rules related with derivatives. So the final answer is like it is. And finally, my last exercise, exercise 8, it's a product. So as the exercise on the quotient, you could use product rule, or you can do first the product and then the derivative. It is much easier to do first the product, so simplifying the product of these terms, and that will be x times x squared x cubed, x times 3x, negative 1 times x squared minus x squared, and negative 1 times 3, negative 3. And that is still, no, I'm sorry, this is not f prime, it's just f of x. And what I'm doing is just applying the rule of exponents that says x to the n times x to the n equals to x to the n plus m. And then the derivative of f of x, it is equals to, again, the derivative of x cubed plus the derivative of 3x plus the derivative of x squared minus the derivative with respect of x of 3, which is the sum rule. And then the derivative of x cubed, which is 3x squared, and it is the power rule, plus 3 times the derivative of x plus 2x minus the derivative of 3. I'm doing it in steps so you can understand. So I use the power rule on the first and on the fourth term. On the second term, I use the constant times a function rule. And I will use again the power rule to obtain the derivative of x. So this will be 3x squared plus 3 times 1, which is the derivative of x, plus 2x minus 0. These are the two rules that I use. And finally, we can say that then f prime of x, or the derivative of the function, it is equals to 3x squared plus 3 plus 2x. That will be my derivative. If you want to write the polynomial in correct order, this will be 3x squared plus 2x plus 3. Both are equivalent expressions, but this is a polynomial in order. Well, I hope you have found this useful. Please check your homework against this explanation, and I hope I see you tomorrow to check if there are still doubts about solving or differentiating functions using the symbol rules. In case that you have applying the quotient rule on exercise 6 or the power rule on exercise 8, if you simplify everything, the final answer should be the same. We can check that tomorrow. See you.